Good afternoon, everyone. So my talk is titled Repurposing Data to Solve Emerging Problems. And I'm gonna walk you through a problem we had to deal with, which is a very common problem. So, first of all, IDC estimates that more than 90% of the enterprise data generated are unstructured. So what this means is that, and let's take a loosely defined unstructured data as text data. Of course, it includes media and so forth. But for the most part, 90% of this data it's unstructured, right? So what does this mean? In the normal course of business, someone might write a report, put it in the database. It's a text field. Police officers can put a complaint, a ticket, and so forth, right? So what happens is that generally how we think about systems analysis and design, when we design these systems, we have a problem in mind, right? So we bring stakeholders together, we try to figure out what the problem is, we elicit the requirements for the system, and we build that system, right? What happens is that system over time, it might not cover all the business needs, right? So that static view for that system becomes obsolete, right? Because it's not following the evolution of the business over time. So if you think about, if this is just basically the requirement analysis. Once you design it, you develop it, you test it, and you maintain it, right? But what happens if you want to try to solve a new problem for the organization? So this is a problem foster care organization. It's a large foster care organization in Florida was having issues with. So case management, it's a very complex topic. One of the main reasons being the increased ratio of foster children to case worker, it's increasing. So one of the first things that once there's budget cuts that they cut, that ratio increases. So one caseworker manages more kids, right? So, it's no different than any other organization that has tasks, processes, data to solve different business problems, right? But in this context, there was a huge problem that was in the media. So, it was the suicide of a foster child, right? So that prompted the Department of Children and Families to, raise the flag and say, are we really doing a good job in tracking these kids that might fly under the radar and that might be taking psychotropic medication and we're not actually paying attention to it? One of the problems of psychotropic medications in this context is that psychotropic medication, it's a black box drug. That means that usually the dosages are meant for adults and they just cut the dosage for the kid, right? So psychotropic medication has us, one of the problems with psychotropic medication is that often these children have suicidal thoughts as a secondary effect of taking the drug, right? So, if we don't pay attention to the kid, it might fly under the radar, and then this can happen, right? So the organization told the case managers, we need to track absolutely everyone that is taking psychotropic medication. So imagine having a full database of, cases, of case notes written by those caseworkers, and these caseworkers would have to peruse over all that data to figure out which cases were positive of psychotropic drug use and which ones were not, right? So that's a big problem. So what we went over saying, if the resources we have, we don't have the manpower to be able to go over all these case notes, the first thing you would ask is like, can technology help? Can we, try to find something specific about the data that would allow us to derive those cases of psychotropic drug use, right? But what happened was that no business process specifically tracked this problem, right? So we said, okay, what kind of data do we have on those databases, right? So that we can kind of like build a decision support tool that can help these caseworkers prioritize their workload. So there's two columns here. The right column, it's called supervisory notes, which is something common in case management. Supervisory notes often has cases that, medication administration or something that needs supervision from the caseworker to the foster child. But the problem is that if we look, and this is just like a very small sample, each row, it's a child, and then what's blue, there's a supervisory note written at that point in time, right? So if you see this, there's sparsity here in terms of, for these children, there was a supervisory note here, and then there was a gap, right? So really, and not all children had these type of notes. What they had was, and the reason for that is that policy would not mandate for the caseworkers to write this type of supervisory notes on a regular basis, okay? So and what happens is that the behavior of the workers is that if I don't have to write it, then, I might leave a gap, and that's no problem. On the other hand, on the left column, we have home visit notes, which is another type of notes that it's mandated for the caseworkers to write one case note at least a month, so once a month at least. So the question becomes, can we use these home visits notes as a proxy for finding whether a kid might be taking psychotropic medication or not? So when you think about psychotropic medication, you think about potential symptoms of the kid or actions that they may take. So the home visits notes, what they would gather there, it's information about how the kid is doing in school, whether the kid looks like has signs of abuse and neglect, whether that kid has fought with other children in the foster home, and so forth. So, this becomes the question. Can we identify these kids based on these home visits notes, which are not originally intended for tracking psychotropic medication use? We're just trying to use these case notes as a proxy. So you might think, well, it's pretty simple. Let's transform this business problem into a technical problem. We know how to do this. It's a supervised learning exercise where we have a case note, and if we get a gold standard from the caseworkers, from the case managers, then we can, try to find a pattern, and then we can use that pattern and infer new cases of psychotropic drug use. So instead of having all the caseworkers go through the entire set of notes, we just have them code a subset of those notes, and then we can use that to infer new cases, right? So this would be the traditional process of doing it. We have the corpus, we have a target variable that it's whether they use psychotropic medication or not. We do some text analytics, feature selection, then we model, and then we evaluate those models, right? So very simple. Trying to go next. Perfect. So these are the results, right? So we found something very interesting about it, and was that, so we did it for 3 different agencies. Think about this large foster care organization as the umbrella organization, and they're their management agencies that manage the workload across different areas in Florida, right? So We track these 3 different agencies, which all the caseworkers under those 3 agencies are trained by the same individual. They work for the same organization and so forth. So the first thing we found out was that it was very interesting why there was a difference between the performance of the different classifiers when trained on data coming from these different agencies, right? Technically, if the trainer and everything, all things equal, they should perform the same. What things happen, right? So just to make a parenthesis here, so definitely we're interested in have higher percentages of recall, right? Because we don't want to miss cases that are positive and label it as not being positive, right? So there's an explanation to this, and I'm gonna backtrack to theory, right? And how we work as individuals and how we perform in the organization. Institutional theory tells us that organizational activity can become a pattern that it's repeated across the organization. If you think about individual caseworkers on those 3 different agencies, if you have a problem, if you're a new employee to an organization and you ask your coworker and say, I have this particular case, how should I report it, right? Most likely, that individual will tell him, here's how we do it, right? How does that other individual knows? Because he probably was in the same situation, and he asked someone before him how it was done. So all these patterns are repeated over time, right? And what happens is that the organization at a higher level, you might not be knowing this is happening at the agency level. So you need to make sure. So this was like a secondary finding that appeared, right? When we did a classifier that had all the training data together with the label psychotropic drug use or not psychotropic drug use, we had a performance. And we were like, out of curiosity, to say, let's break it down by agency. And that's what happened, right? So what institutional theory considers is that all these processes create structures inside the organization that become authoritative guidelines over time. So this, to put it simply, this is how we've been doing things, and this is how we're going to keep doing them, right? So if you look at that from a data perspective, you see there's differences between the data entered into the system by one caseworker from an agency as opposed to other one. So the next question was, how can we know for sure this is a fact? So there's something called stylometry. If you're not familiar with stylometry, it's just basically authorship analysis. So it's been used for the Federalist Papers, to find the Unabomber Kanczynski based on his write-up, be able to infer for a fact that he was the author of these unknown writings, right? So we were trying to say, can we abstract that idea of authorship analysis, and can we kind of create an analysis that says, are these organizational agency also have a certain style that it's similar across time? So meaning, if I grab a case note, can I predict where that case note is coming from, whether it's agency A, B, and C? And we found that we were able to find with high accuracy, based on the case note, where it was coming from, which is a big thing for the case foster care organization, because now if we bring back to our problem and we see that one organization is better at finding those differences, let's look, what are they doing to be able to communicate that to the other agencies that are not performing as well, right? So the idea here is, there might be something going on. Is there an intervention that it's happening here that we don't know of? So we went and we talked to the individuals at this particular agency, and in fact, one of the managers at that organization had explicitly asked caseworkers to be more specific when someone was taking a medication, no matter what. If you're taking medication, ask the individual that they're taking medication and make notes about it, right? So we go back to psychology theory and we look into cognitive research, and we think cognitive research is a perfect explanation to this, because what we're trying to do, if you think about the data in a system, they're just a representation of the world. An individual looks at the kid, puts their notes of what they're looking, and that representation is put into a system. So there's two concepts that can help explain this in cognitive research. One, it's cognitive economy, okay? So when you write, you try to maximally abstract individual difference among objects, right? So if we go back to the previous talk, for instance, right? You can have, if you're doing crowdsourcing or a city science project, you can say, oh, or that's a zebra, or that's a dog. But if you're more knowledgeable about that context, you can say, at the species level, oh, that's a German Shepherd. So this information, it's context-based, because if I have a German Shepherd, or if I have a certain health condition, I'm more knowledgeable about that condition, and I can go deeper in that structure, right? So if I don't know what dog looks like, I would just, what the species of the dog, I'll say it's a dog. If a kid doesn't know the difference between a dog and a bird, that kid would say, oh, I saw an animal, for instance, right? So if we think about information, it's hierarchical. And if we look at an ontology of concepts, that taxonomy can go from more abstract to more specific, right? So inferential utility, on the other hand, in cognitive economy, tells us that we're able to predict more attributes out of more specific data, right? So knowing that a dog is a German Shepherd allows you to make more inferences than if you know something, it's an animal, right? Because the animal can take many forms and shapes, right? It could be anything, a dog, a bird, and so forth, okay? So here it is, right? So, based on this taxonomy, which one has a higher cognitive economy? And which one provides a higher inferential utility? So the higher cognitive economy, it's animal. Because by knowing something that's an animal, we encompass more objects under animal, right? Whereas if we know something, it's a German Shepherd, then we need to know more terms in order to identify different objects, right? Because now I see a bird, but a German Shepherd doesn't serve me well to describe that bird. Whereas if I have, animal still encompass that bird. So we bring this idea of cognitive economy and inferential utility to our case study, and what we saw on the cases was that the more specific these caseworkers would write the case notes, the more inferences we can make, right? So, based on that two concepts and those two ideas that I introduced in the previous slide, so we have the excerpts coming from case notes from two different childs. Which one is taking psychotropic medication here? Although not explicitly, right? So, if I'm a knowledgeable person and I didn't know, Vivance was a psychotropic medication, but someone in that context would know, right? So basically, knowing this term, I can infer that kid is taking psychotropic medication. And that inference, it's almost one-to-one, right? So in this case, there's a one-to-one mapping, knowing that even the dosage, that the kid is taking 5 milligrams of Vivance, automatically I know it's taking psychotropic medication. There's some other things that might signal that, right? Whether there's signs of abuse and neglect, whether the kid is paying attention in school or not, whether that kid has been, starting fights at school, whether the appearance of the home where the kid is being visited at, it's clean and tidy. So whereas on the second excerpt, we have a kid that if we look at that taxonomy, that hierarchical taxonomy, medication falls at a very higher level, right? So knowing that something is a medication, it could be a psychotropic medication, but it could also be a non-psychotropic medication. The kid might have a fever, and then the individual reported the kid is taking it's taking medication, right? But at least if that person said the kid took Tylenol because he was not feeling well, at least we know Tylenol, we can make inferences that Tylenol is not a psychotropic medication. So this was a kind of like a neat finding in terms of looking at how individuals did things different, although the training they had a form, right? So now the key is, let's try to take that idea of inferential utility and let's have other people at the organization report the case notes in a way that it's more specific. So one of the things, if we think about unstructured data from a system analysis design, it provides flexibility. It gives the user the flexibility to put whatever they need. But at the same time, you might not get the data that you wanted, okay? So think about a crowdsourced project like the one we saw before, right? So if someone was entering sightings of species, right? If I'm a citizen scientist and I'm not an expert, I might see a sighting of a dog, but I don't know it was a German Shepherd, right? If you put a user interface that captures that information, let's say through a drop-down at the species level, and at the species level you had German Shepherd, Labrador, and some other species, or even deeper in the taxonomy, then I wouldn't be able to contribute to that system because my knowledge, it's limited to knowing that's a dog, but that's it. So that's the kind of like the trade-off between providing flexibility to the user to put whatever they want, but then are we capturing what we want to capture out of the user? So, it's the trade-off between using unstructured data and structured data. So why H2O, right? So this is my last slide. I think the point that summarizes here, it's the fact that performs incredibly well out of the box. So I heard about H2O from a friend and told me, hey, have you tried this? And I was like, no, I already have the paper written. I have the different classifiers there. It's perfect. So I said, well, you should try it just to test it. So I actually plug H2O. That's why I dedicated like a magic yellow box here. And I had to rewrite the analysis section because it outperformed all the different models I had already tweaked. So this is kind of like the main one, why H2O. Also, it has the flexibility. You can go from graphical user interface to open source. Great at not overfitting as well. So we wanted to have something, if you're trying to implement some of these, it's very challenging not only from the technical aspect, but you really need to convey that this is just a decision support tool rather that you're gonna replace a caseworker or a case manager, right? So we were pretty straightforward with the caseworkers and say, this is your job. We're just trying to prioritize cases that might be flagged as positive cases. So, just have it in mind and do your process as you do it and kind of like use this as a support tool. So I have like 3 minutes of Q&A if you have any questions. Yeah, so very traditional text mining. So what we have the features and what we use is the information utility. And I kind of like flew by this, but the idea of those terms, if we think about those individual terms, and we think about the entropy or the information gain of knowing a certain term, it's higher for terms that were more specific. So if we were to get, for instance, the top 10 keywords of each of the different agencies, that agency B that had a better performance, if you see those 10 terms were definitely more specific than if you were to grab the 10 terms coming from the other agencies. Yeah, did you look at, and it goes back to that second question as well. The most predictive features for sure were names of drugs, right? So Adderall, Vivance, Zoloft, and so forth. And then second, things related to whether the kid had a fight or not. So, fight, bruise, things like that. So those were the most predictive features. I see someone's typing a question. What's that? That's a good thing. That's a good question. We didn't go because the challenge there is that you don't have that many cases of suicide. So it's a very, very small signal there, and we wouldn't be able to have enough items to train on that. Any other questions? Did you get better performance for kids with more data points? So that's another good point that you raise up. I have 5 seconds. But basically, there's a challenge with this data. And the challenge is that the more data points come in from a children, these children might come on and off of taking psychotropic medication. So the temporal window, and that's something we need to work on next, it's setting temporal windows, right? Because what we did was someone in the gold standard labeled something as taking psychotropic medication, and we grabbed the data a year back for that kid. But there might be instances from that data that were in a period where the children was not taking psychotropic medication. So that's actually a very good point. What about using an unknown category for when don't know that level of specifics? I'm not sure about this one. Can anyone rephrase or? Yeah, so that's actually other part of the research I do, basically saying, if we don't know, if that individual user doesn't know that specific level, that deeper level, it doesn't matter. Let's grab the data he has, right? Because, for instance, if I'm in a particular context and I saw a bird that was white and had this other characteristic, if I say, well, I'm in the Everglades in Florida, I can make that inference of that's probably a blue jay because I know there's blue jays in Florida or other types. So you can complement other data that might be contextual and try to make those inferences. So I ran out of time, but if you have any other questions, I'll be happy to answer offline. Thank you.